Today, we will be learning about 3D shapes. Two-dimensional shapes like polygons and circles take up area, a space on a flat surface or plane. 2D shapes have width and length, but no height. Shapes in 3 dimensions or 3D have volume, meaning they take up space and have width, length, and height. You take up all 3 dimensions, and so do most of the objects around you. You must have space for everything with 3 dimensions to fit into the space you have. No 2 objects can be in the same space at the same time. Suppose you are sitting in a chair, studying. Your dog leaps into your lap. Can your dog occupy exactly the same space you occupy? No, your dog may try, but the 2 of you cannot be in the same place at the same time. Let's discuss the mathematics of 3 dimensions. Shapes that exist in 3 dimensions all have width and length just like their 2D relatives, but they also have an added dimension, height, which can also be called depth or thickness. In mathematics, an infinite number of squares could occupy the same area on a plane because they have no thickness or height. Adding the 3rd dimension, this becomes impossible. A cube, the 3D version of a square, will have identical measurements in width, length, and height. No other cube can occupy the space it takes. In real life, you cannot have squares on top of squares taking up no space. A sheet of notebook paper may seem very thin, but think about a package of 200 sheets. It has measurable thickness. One sheet would be 1/200th of the thickness of the whole stack, so even a sheet of paper is a 3D object. 3D solids are convex shapes having width, length, and height, or depth or thickness. They occupy space, meaning they have volume. You are familiar with many models of these 3D shapes, and here are some examples. Many other 3D solids exist too. A whole category is called the Platonic solids. These are tetrahedrons, which have 4 triangular faces, cubes, which have 6 square faces, octahedrons, which have 8 triangular faces, dodecahedrons, which have 12 pentagonal faces, and icosahedrons, which have 20 triangular faces. Unusual 3D shapes in mathematics include the torus, which looks like a donut. Another strange shape is the pentagrammic prism, which is found in December ornaments and gift boxes. Even our own planet is an unusual type of 3D shape since it is not a true sphere. It is an oblate sphere. One of the most unusual 3D shapes revealed only recently is the scutoid. Once mathematicians and scientists discovered it, they found it already in use in insects and human skin cells.